Okay, this lesson is essentially a recap, teaching you how to solve all the forms of quadratic equations that we've gone over thus far. Okay, solve the equation for the variable. Okay, the first equation, example 1, we have 3x to the second power minus 6 equals 39. So these all have two answers. Now, without parentheses, you label A. There's no B because there's no x. There's an x squared, but not an x. And these are both c's. Okay, with AC's, we don't make boxes. We just get that x squared by itself. So I plus 6. And that takes me to 45. Then you divide by, make a wall. When you have A and C, make a wall where the A is at. Okay? So because you get rid of that, then divide by 3. And that is 15. Then you apply the square root. So x is equal to the positive or the negative. Now let's see if 15 is a perfect square. It's obviously not. So I'm going to attempt to divide it and rewrite it in two square roots. So is 15 divisible by 9? Nope. 4? Nope. So guess what you're going to do? You're just going to keep 15 in its square root. The square root doesn't go away. Okay, you weren't able to get rid of it. So it's square root 15 and square root 15 with a negative. Okay, next problem. We have 3x to the second minus 18x minus 81 equals 0. So we have two solutions for x. Now we have x, all my x squareds are a's, all my x's are b's, and then c. So now we have a, b, and c. So anytime there's a b anywhere in a quadratic equation, we have to see the 0, and it's there, so you're set. Okay? Put set when I see equals 0, because that's what I want. Doesn't have to, AC's we don't set it equal to 0, but ABC's we do, and AB's we do. Okay, so when I have A, B, and C in the house, I want to do GCF and table, but I want to make sure I'm going to be able to find something on my table, and that's what this discriminant is used for. Okay, so B, negative 18. 4, A is 3, C is negative 18. So I punch in my square root. We need one parentheses comes up on its own, but we need a second one just for the negative 18. Close it, raise it to the second power. Then I subtract a factor of 4, and then a factor of 3 right next to it, then a factor of negative 18. Oh, I did that wrong. Okay. It wasn't negative 18, it was negative 81. So second, let's try this again. 4 and 3, my bad, I'm struggling here. Negative 81. Okay, I got a whole number. I don't care what the whole number is, but the fact that that came into a whole number means the factoring's good to go. So with ABC, we see if we can do a GCF. And then we see if we can factor the trinomial further with a table, which I know we can because I got a whole number with this. Okay, 318, 81. Now if you look in the third row on a multiplication table, obviously 3 and 18 are in the third row, and 81, just look at it. I mean, it cuts off at 75, but then it goes 78, 81. So that would be all in the third row if it kept going. So 3. So we place a 3 right here before the parentheses, because that's where I'm going to write my factoring. And 3 would not have an x because we have this 81 here without an x, and A is positive, so the GCF's positive. So then I divide everything by 3. That's going to be an implied 1 with x squared, that's my new A, minus 6x, that's my B, and minus 27 is my C. Okay. Alright, now I look to factor this trinomial here. But now it's 1, 6, and 27. So 1 times negative 27 is negative 27. So it's a positive times a negative. And we have to add to try to get to negative 6. So 1 and 27 is not going to do that. That's not even close. 27 is not divisible by 2. It is divisible by 3, and I get 9. So 3 plus negative 9 is negative 6. Okay, what's my A coefficient? It's the implied 1, okay? So really the 1 might as well not be there, and it's just x squared. So that's just an xx parentheses. So xx plus 3 minus 9. Now carry those over next to your 3, and the original expression has been written in factored form. So f1, f2. This doesn't have an f because it doesn't have x with it. If it was 3x, I would label it with an f, but it's not. So I subtract 3, I get negative 3. And then I add 9, I get 9. Negative 3 and 9. Okay, example 3. I have 3 quantity x plus 3 to the second minus 7 equals 101. Okay, so there are two solutions for x, but with that parentheses, first off, you can't distribute because there's a second power. That means the distribution is blocked. Okay, no rainbows. See, if the second power was there, I'd just distribute, but it's, yeah. So I label it A, H, K. Okay. Now with an HK, first off, we're going to remove the parentheses from the equation. So x plus 3 equals, but we have to bring it back. Okay. So I replace the parentheses with just an H with a 3. A is 3. Remember, H is to the second. Don't forget that. Minus 7 equals 101. Don't forget the second power on your H. Okay. So 3h to the second minus 7 equals 101. Now I solve it like an AC, okay, where I get the h all by itself. So that's 108. Then that's going to be 36. Okay, now h is equal to the positive and negative of the square root of 36. Now the square root of 36 is right here. It's equal to 6. So no more square root, and I just write 6. But then I don't put that here. X isn't equal to 6. The expression x plus 3 is equal to 6, or negative 6. So I minus 3, and I get 3. There's your first answer. Then we minus 3, and we get negative 9. There's the second. Okay, next problem. 4x to the power of 2 minus 3 equals 2 plus x. Okay, I got two answers. No parentheses, so label A, what you have for A's, B's, and C's. So A, I have a 4. B, I have this 1x here. And then C's, I have actually 2 of them, negative 3 and 2. Well, with A, B, C, we have to have the equation equal to 0. This has to be set equal to 0. So I'm going to minus 2. And I have a C there I can minus 2 from. Then I minus 1x. I don't have a b here, so I'll just put minus 1x, but remember to put a b with that. So line it up. A comes first, 4x squared. Then b, minus 1x. Then c, negative 3 minus 2 would be negative 5. And now we're set. Now we apply the discriminant. You'll see in the next video the next lesson, why this is important to do. B, negative 1, A is 4, C is negative 5. So I go second square root, negative 1 to the second, minus 4, 4, negative 5. Okay, nice whole number, so I'm good to factor. ABCs are factored using GCF, and then setting up your big box for the table. Okay, 4, 1, and 5 would just be a 1, and you get this C here without X, so you can't do an X, and it'd be positive, because A is positive, so really the GCF is not worth it. So 4 times negative 5 is negative 20, so that's a positive times a negative, and we're adding to try to get to negative 1. 1 and 20, nope. 2 and 10, nope. 3 is a decimal. 4 and 5. Yep, that's -1. Okay. Now what's your A? Your A is not an implied 1, it's equal to 4. So that means we have to do the grouping. Okay. Oh, good old grouping. Parentheses plus parentheses, then line parentheses plus line parentheses, then big line, big parentheses, and you put a parentheses on the line. Okay. All right, now to know what you're grouping, you got to rewrite this. Okay. Before where you did your last ABC. The last time we labeled ABC was here, so we have to rewrite that. That's the one that has to be replaced with these two. So we are now going to have 4x to the second plus 4x minus 5x minus 5 equals 0. Okay, so now you're going to have 4x squared plus 4x and then negative 5x minus 5. Okay, now remember when you're dividing, you want to first check where you need to put negatives. Not here, because that's a positive in front. Here, you'll need the negatives, okay, because you have a negative in the front. Okay, x's. Okay, we got x squared and x, so we need to put x on the bottom there, and we don't put x here, because that's where the constant's at. Can't divide a constant by x. Okay, 4 and 4, we'll divide those by 4. 5 and 5, just divide them by 5. You don't need to look at your chart. So I pull out a 4x here, okay, a negative 5 here, and then the parentheses should match. So it's going to be 1x plus 1, because the x's cancel in the second. And this is the same thing, 1x or x plus 1. So what I can do now is pull out 1x plus 1, since they match. Cross them out, and then I have 4x minus 5. Okay, now rewrite what you had. Okay, you're factoring. GCF was, I didn't put a GCF, so I just start writing my parentheses. 1x plus 1 times 4x minus 5. Okay, so 1x plus 1 equals 0, or 4x minus 5 equals 0. So minus 1, you get negative 1. So 4x equals 5, then divide by 4, and that's 5 over 4. Okay. Okay, last problem. We have 2x to the power 2 equals 8x. So there are two answers. Okay. So you don't have parentheses, so what do we have for A right there? What do you got for B? You got any C's? You don't. So it's just A and B. Okay, with A and B, we have to have it equal to 0. Okay, just like you do with A, B, C. It's the AC's that don't have to be equal to 0. Okay, so we need to minus 8x. There's no B over there, so we just put it at the tail. It's a trailer. Okay, so A, you got 2x squared. B, you got minus 8x. Okay, AB's, we just do the GCF, and that gets us where we want to be. Okay, 2 and 8, that'd be 2. Well, and you also need an x, because when you have A and B, B had the last term's got x. Okay, see with ABC, the last term has no x. Now your A is positive. Okay, so GCF's positive. And you divide by 2x. Okay. So it's going to be 1x minus 4. And there you're set up, okay? Your factoring's done. 2x times 1x minus 4 equals 0. So I've rewritten that side in factored form. So F1, F2. Okay, so we'll divide by 2 here, and that's 0. We'll add 4 here to get 4. So 0 and 4 are the answers. Okay.